Now, so this technology can be put into practically every system that is used in space. Just so you know, this model is under 13 kilobyte in size. So it's a perfect, made for a microcontroller like this. And you can have as much as 10 commands running on this under 110 kilobytes of the model, and it has over 1 megabyte of flash. So there are applications that you can port easily, make your devices smart in a very low cost and cost effective manner, and do it easily with using our platform. And so that brings me to how do you augment intelligence, right? By itself, machine learning will not create a system. It is a part of a bigger system. In this case, NASA Ames Center has, a Astrobi research department, which has designed three different robots, Honey, Queen, and the Bumblebee. So these three robots that I'm going to show in a video, they do multiple tasks. So if they can be made to respond to a human command, and it is easy because they're so modularly designed, it would be awesome. With that, let's move on. Astrobi system consists of three cube-shaped robots, software and a docking station used for recharging. Augmenting intelligence with IoT or MC module with Astrobi robots using AITS's tinyML Studio can be achieved in a matter of minutes, as you will see in the next slide. Astrobi has a highly modular hardware and a software design that makes it possible for the robot to do a wide range of tasks or experiments. Each robot has a 3 payload base attachment points for which station crew can easily install new hardware modules. One can easily design or add a brand new open source machine learning research as an IoT or MC module to these robots in a matter of minutes. For example, adding a keyword spotting or taking commands for performing housekeeping chores such as monitoring equipment and performing inventory. So with that, let me take you to how you can use our platform to design a simple wake word. And so this takes me to a screen where, so this typically takes about half an hour to an hour to give you a production-worthy, component, like the one you see in my hand. For example, we have tested this on this particular board. It works beautifully. And there's a video that shows the operation and stuff. In case you're interested, let me know. I can forward more details on this. So what this is essentially you would use your voice, and that would contain anything but hot word. So let's say if your hot word is "Hey NASA" or "Hey Apollo" or whatever it is, right? You would say that multiple times and repeat it for a minute or two. And that becomes your background data set. So this is capturing these data sets on the fly. Typically, you need more than 1,000 samples, but you can get started with as little as 50 to get to 70% accuracy. And once you have that, then you record your hot word for over a minute with anywhere from 20 to over 50 samples with 1 second per sample. And with these two data sets, once they are ready, you can just push the button train, and our servers will take this data set from here and start to train the model depending on the length and the quality of the model. It would take a few seconds to a minute. So right now I'm done with the audio wake word, and then you can record the hot word. And I'm right now, like I said, for the lack of time, we can't do that. But it's just pretending as if I'm, recording the hot word, and then we will push the train after it is done recording for about a minute. Now the training will go to will take these voice recorded voices, turn them into wave files, slice them, dice them, do a number of other things, and create a network and then train that network on top of this. So I stopped it in the middle of less than a minute. So it says warning, your recording is less than a minute, and I'm fine with that because it's just a demo. And then you train. So right now, it's taking that data and dicing it one sample per second, and doing the training on a predefined network that we have. It's a proprietary network that we have designed for resource constrained devices. Now here it says with that kind of model, you have an accuracy of about 87.5%. And your model is ready. It's already trained within a minute. And now you can test that model. Test that model by repeating the hot word again and see if your hot word is actually captured or not. And again, depending on how many words do you want to test, you continue this and stop it when you're ready. And so you pick a model that you've trained. You can train multiple models. Like you see, I keep demoing this technology to several people, so I have hundreds of tens of these models. And then you test, and this takes you to a different screen, which if we were doing the right thing, it will show us that in this recording clip, it was detected so many times. So this is the test sample that you saw that I recorded, and it seemed to have caught my hot word once. So there was likely something that I did in the training data set and just got it here. So this is one-time detection. So now you're ready. So your model is ready. Everything is beautiful and beautiful. And all you need to do is to pick up where would you like to deploy this. So you can pick Raspberry Pi 3, Pi 4, Ubuntu, any Linux variant, or this board, Arduino Nano VLE Sense, or some other board, or this ST 32F4 that I have in my hand, and some of the other ones. And if you're using your own, let us know, we can support that too. And all you have to do is to hit the compile. And this gives you everything that you need to deploy this model onto this device. So right now I'm downloading a .a, which it compiles using our compiler technology, and gives you that .a that is downloaded successfully. You can also convert that into a binary that you can flash onto some of these devices. For example, instead of picking the .a, I could have chosen the .exe. And if you have the right license, we can also give you the C++, WebAssembly, or some of the assembly code after compiling this. So the opportunities are unlimited. If you find it useful, let us know. And it's not just limited to that. We have several other tools and technologies that go behind creating this platform. So this was a simple demo of how do you create simple wake word detection using our technology. And so it's as simple as